This is the review for Concept Quiz 7. Let's look at the first problem here. We need to write this equation in graphing form. Find the vertex, sketch the graph. So given this equation, the first step is to move the c value to the other side. We're dealing with an equation of the form y equals ax squared plus bx plus c. We're trying to get it into graphing form, which looks like this. So if I moved the c to the other side, I get y minus 13 equals 5x squared plus 10x. And we're trying to complete the square, which means we're trying to get a trinomial here that will factor out to look like this. Before I do that, I'm going to factor out the a value. In this case, a is equal to 5. So taking that out, we get 5 times x squared plus 2x. Now in order to complete the square, so in order to make this into a perfect square trinomial, we need to add a number here, which means we need to add a number to the other side of the equation as well. So to calculate what this number should be, we're going to use the formula b divided by 2 squared. In this problem, b is equal to 2. We don't want to use the original b value of 10, but the new b value of 2. So 2 divided by 2 squared would give me a 1. On this side we added a 1, but if you were to multiply this out, you're really adding a 5 to this side, so that means we have to add a 5 to this side. So that gives me y minus 8 equals 5 times this. I need to factor so that it'll look like this. This is a perfect square trinomial, so what you'll notice with all the perfect square trinomials is that you get two of the same factor, x plus 1 squared. So now it's in graphing form. Your teacher may have written graphing form with the k on the other side, and actually this up here was written incorrectly. This should be either y minus k equals a x minus h squared, or you may have seen it like this with the k on the other side. So adding the 8 over to this side, both of these are acceptable formats. So we have graphing form, y equals 5x plus 1 squared plus 8, which gives us a vertex of negative 1, 8. When you sketch the graph, you should first plot the vertex. So negative 1, 8 is my vertex, and then just sketch whether the graph opens up or opens down. A is a positive number, so I'm going to sketch a graph that opens up. All right, in part B, we have a graph given and several equations, and we're supposed to choose which equation matches the graph. Let's first look at the vertex. The vertex of this graph is at 3, negative 2. The only equations that have a vertex at 3, negative 2 are 2 and 4. So I'm going to cross out 1 and 3. Since those two have a vertex at negative 3, positive 2. The only difference between option 2 and 4 is that one has a negative a value and one has a positive a value. This graph opens down, and so we know that the a value must be negative, so our answer is option 2. In this last problem, in part C, we're going to fill in the blanks to complete the sentence. If we compare this equation to this equation, looking at the a value, here we have an a value of 2, and here we have an a value of 1. We know that if our a value is greater than 1 or less than negative 1, we're going to have a graph that is stretched. So in this case, since a is greater than 2, or I'm sorry, a is greater than 1, we have a graph that is vertically stretched, not compressed. Now let's look at the vertex of each of these. The first equation has a vertex of 0, 7. The second equation has a vertex at 4, negative 7. So we're shifting this graph, looking at the options here, either left or right. If we're going from 0 to 4, we're going right. And that's 4 units to the right. Looking at the vertical shift from 7 to negative 7, we're shifting the graph down. And from 7 to negative 7, that's 14 units being shifted in the downwards direction.